Hi, I'm Juning Han. I will introduce our work blind image decomposition. First, I'd like to raise a question. What is rain? In most time, we think rain exists as rain streak. In a dry rain environment, when we look through the glass, rain may also exist as raindrops. What else may come along with rain? When the temperature is under some conditions, the falling precipitation can be slow. And do not forget haze, which also comes along quite often with raining. The aforementioned four components may occur solely or as an arbitrary combination in real world. We need to consider the existence and intensity of every component. When we talk about raining, it can be one of these 6 cases presented here. Here is a demo of the blind image decomposition setting. We predefine some source components containing images of a certain class. We randomly choose images from different sources, then mix them. We want to have a method to predict the sources involved in mixing, as well as separate and reconstruct individual images involved in mixing. The goal of a BID task can be summarized using 2 keywords, predict and separate, where we want a model to predict the components involved in mixing and separate individual images involved in mixing. As BID is a novel task, we designed a simple yet general and flexible model to perform all kinds of BID tasks. Our model is named Biden, which is short for Blind Image Decomposition Network. The design of Biden is based on GANs. We introduce a multi-scale encoder and multiple hits corresponding to each source component to perform the separate and reconstruct task. The source prediction task is performed in a discriminator. Let's look at BID datasets. We built 3 BID datasets in total. In this talk, we will focus on the later 2 datasets and their BID tasks. Task 2A is raining in dry rain, where the raining task can be important in a dry rain environment. We employ cityscape images as rain-free images. Other components are rain streak, raindrop, haze, and snow. We follow the physical image model to generate raining images. Here we present the results of Biden on 6 testing cases. Except following drop masks, Biden overall performs well on all source components and shows very high accuracy in the source prediction task. Here are some real results of Biden and other baselines. Baselines are also trained in the BID setting. We can see that Biden is good with all components, while strong baselines like MPRNet and Rainstormer sometimes cannot remove raindrop and haze. Task 2B aims to compare the BID training setting and conventional image decomposition setting in real world. Here we show some real results of MPRNet and Biden on real images. Both MPRNet and Biden are trained with conventional image decomposition setting and BID setting. In the conventional setting, we train models with 4 times more data and training iterations than the BID setting. In summary, models trained under the BID setting are more robust in restoring real-world images. Quantitative results further validate the generality and robustness of the BID setting in real-world scenarios. Models trained under the BID setting are good at processing all kinds of natural images. Task 3 is designed to jointly perform multiple tasks with uncertainty in one go, which is an attempt to build a unified model for various low-level vision tasks. We have shadow, reflection, and watermark in this task. We also follow the physical image models to generate mixed images. In this task, baselines are trained in the shadow removal setting. Though not as good as strong baselines designed for shadow removal tasks, Biden still shows reasonable results. We compare Biden to other shadow removal baselines. Biden trained under the BID setting showed lower results than those shadow removal baselines, which suggests the BID setting can be very challenging. In conclusion, we propose a new task that better adapts to complex real-world environments. Codes and datasets of this paper are all available. Thanks for your attention.